Hi, everybody. Welcome to the only security talk in this conference. Thank you. Welcome to the talk. My name is Dmitry, and I've been a security engineer. Sorry, Amit? I've been a security engineer in the past 4 years in Wix, in my almost a decade journey in Wix. And this is my friend and colleague, Dmitry.
Also, you can.
Yep.
Yeah, I've been at Wix for over 8 years. I was on a product team for a while, on an infra team, and now almost close to 3 years as a backend developer and chief Krampus herder on application security team.
Thank you. So today we're here to talk to you about application security testing, or more specifically, how we managed to overcome some of the challenges that exist across this industry by taking the challenge to build our own in-house framework from scratch. So let's talk about testing. First, it is used by both attackers and defenders, where attackers are using application security testing to find vulnerabilities and exploit them, and defenders use testing to eliminate vulnerabilities wherever they want to eliminate vulnerabilities. And there are countless solutions to application security testing. Like, there's a myriad of open source tools, and maybe just as many, if not even more, off-the-shelf commercial solutions that cost a fortune, to be honest. And while we have tested so many solutions, we found that none of them can actually satisfy our needs in Wix in terms of quality, in terms of scale, and in terms of comprehensiveness of those tests. So what we found is, like one American economist said, is that there are no solutions, there are only trade-offs. So to understand the landscape of the tools that are out there and the methodologies, let's explore application security testing landscape. And first, we need to set some terminology. In every application security test, there is a source and a sink. It also translates to the vulnerability where untrusted data is introduced, such as an HTTP request, an email, a file upload, or any other source where the attacker can control the data. It then goes under some data flow, whatever functions are out there in the server, and it goes into the sink where this untrusted data is used. This can be a subsequent HTTP request when there is an SSRF vulnerability, and it can be an SQL query where data is not escaped properly, or it can be the browser where the victim is receiving a response, and it can be an XSS vulnerability where attacker executes code on a victim's browser. So once we have those concepts, we need to understand that the more sources and the more sinks we cover in a test, the more comprehensive and full our test is, and the more we can be sure that we are actually testing reliably our attack surface in Wix. To measure the different approaches, we need to set some criteria. So we will use speed to measure the feedback loop of the test. How fast can we get some results? We will set a quality to measure the number of false positives and false negatives that a test produces to understand whether we can rely on the results of this test to interrupt developers in their workflow. And we will use coverage to measure the reachability and comprehensiveness of the test, whether it can actually test all those APIs that we will talk about soon. So first, we have probably the most common testing methodology, and this is SAST. The SAST is a process of scanning the code, that's why static, to find the vulnerabilities. This involves typically running a server that parses the code and matches it with common patterns of vulnerabilities. And unfortunately, SAST cannot detect what it cannot see. So in a typical scenario, a SAST can miss vulnerabilities that are hidden in third-party libraries and even second-party dependencies. So there are a lot of false negatives in this scenario. And also, this process involves heuristics and inference, which produces a lot of false positives. So the reliability of the results of this test are not very good. But it's fast. It's extremely fast. We can run it on every PR, every commit, whenever. So let's summarize the effectiveness of SAST. We have great speed, but the quality and coverage doesn't satisfy our needs to cover all of Wix continuously and interrupt developers. On the other side of the spectrum, if we can call it a spectrum, we have penetration tests, or PT. And the PT is a process involving a human tester interacting with an application to detect vulnerabilities. A tester can monitor many sources and many things at once and manipulate them. And this is the most comprehensive test that exists out there. Typically, it's done with a local reverse proxy on the tester's machine, so it's easier for them to manipulate the requests and responses. It's performed against a real application, unlike the static test that we talked about before. So the results are very reliable, but it's extremely slow. It cannot be automated beyond iterations that are focused on very specific requests. So it's a very limited resource, and we cannot rely on it to test all of Wix continuously. In summary, very low speed, but amazing quality and great coverage. Well, there must be something out there that we can use, right? So there's the new thing. It's called dynamic application security testing. And dynamic application testing is the process of typically obtaining the list of API endpoints you want to test and their schemas, either via crawling or via schema inventories, and then running a set of tests against these APIs. A DAST is mainly using the response sync for detection of vulnerabilities, and it actually runs against a live application, so the results quality are quite good. This process can also be fully automated, so it's pretty fast. Good, fast enough for us. But its coverage is actually low, despite being able to test all of the APIs. But why is that? Well, the problem that even DAST doesn't solve is that many APIs rely on existing application state. Look at this example, for example. To invoke the create session API, a program needs to provide a schedule ID. And there is no way for an automated program to actually guess how to obtain a schedule ID. It cannot be detected. It would probably just be a better request response or something like that. Another example is that we need to obtain a fulfillment ID to invoke the update fulfillment API. And the same goes on for so many APIs, and specifically in Wix, I think the most of the APIs are contextual, like requiring some context. So what we understood, having tested so many tools and tried so many approaches, is that first, the majority of Wix APIs are contextual. So we cannot just skip those APIs and not test them, accepting some external tool. And the second is that we must run the client-side JavaScript to be able to create this backend state required and to form a proper request in order to test an API that relies on some context. So we did not give up, and we decided to build our own tool from the ground up. It's called Krampus. Dmitry here will tell you why. And what we did is we made some trade-offs. Instead of getting an external tool provided by another company that we don't need to maintain, develop, and take care of, we are building our own tool from the ground up. We took advantage of the Wix TDD culture, and specifically the tests that are written as part of a typical development workflow by the developers, not by us. We built it around and into the Wix testing infrastructure which enables us seamless integration across the Wix toolset for a developer and us. We introduced custom sinks. If you remember, we have a source and a sink for a test in application security. And we were able to introduce custom sinks to cover more types and groups of vulnerabilities. So our test capabilities are constantly growing. And finally, we gained an ever-expanding coverage automatically, because once a developer creates a test without us being involved at all, Krampus just picks it up and tests it for security. And to understand how this works, please welcome Dmitry.
Thank you. So, what is Krampus? Can you hear me? Yeah?
What?
So, what is Krampus and how does it work? So first, as promised, a couple of words about naming. So we had, at least in the past, Christmas themed naming theme at Wix. So we had Santa, which was our site editor and site viewer. And we had Sled, which is a browser-based end-to-end testing framework infrastructure. And now we've built Krampus, which is this evil Santa which finds and punishes naughty children or naughty developers. So let's take a look at a typical front-end developer workflow at Wix. So a developer will write their front-end code to implement their feature, fix a bug. They hopefully also write a Sled browser-based test scenario. And so then they create a PR. The PR, they push it into GitHub. The CI, our Falcon CI, will run the PR, build the code, run the test scenario. And at this point, Sled will start up their test. It will start a headless browser. And it runs in this Lambda-based environment, so it's testing the code from the outside. And so in the browser, in this headless browser environment based on Puppeteer, the test scenario executes, so it loads some kind of Wix app, and it exercises the front-end code. And as part of it, it also naturally exercises our Wix APIs. And also the test environment, the Sled test environment records all kinds of things about the execution. Among them, the network request log that the browser makes, all the requests. And at the end of the test, a developer can see the results in the Sled console. And as you can see, there is this network log, very similar how it looks in Chrome DevTools. So this was the normal Sled test flow. So where does Krampus come in? So Krampus listens to events from the Sled infrastructure, and for some tests, it will replay them in a special Krampus mode in a separate Krampus environment, also AWS Lambda-based. So it's important to note that it runs after your CI build is finished. It doesn't fail your build, and you don't see the results of Krampus. It's a separate system. So it doesn't really interfere with your CI. So what does this special Krampus mode, what does it do? So we install special interceptors that for some requests will inject security payloads. And so the test runs normally. It triggers all kinds of Wix APIs, and for some of these APIs, we will inject some security payloads. And so we will, if we see a URL, we will inject. Sometimes we will inject a a special URL that Krampus controls and listens to. And sometimes we will also inject some snippets of JavaScript that we hope will be executed in the browser as an XSS, cross-site scripting. So there is also, eventually there'll be a call to a URL that Krampus listens to. So we have an SSRF listener, we have a listener for XSS, and eventually, if one of these are triggered, we have this private channel for the application security team where we will see details of our successful exploitation, and our application security experts on the team will take it from there and contact the developers or the owners of the service if it's actually verified to be a vulnerability. So to summarize, the flow is that a developer developers do their work, they create a PR, the Sled runs. For some tests, Krampus will replay them and inject some payloads into the network request flow of the test. So we also made some optimizations. So there are some flows where there's not actually any opportunity to inject anything. There's no URLs, no XSS, and stuff like that. So we will skip those. We have a dry run stage that runs before we decide to replay tests, and we skip the tests that don't have any injections that we can make. And we also limit the number of times that we run each test or replay each test per day. So there are some numbers. So Krampus coverage, we have over 80,000 replays per day on average. We have 35 distinct APIs and distinct injections per APIs per day. And we directly test around over 700 distinct services or artifacts. So how can a developer opt in? So basically, if you have a Sled test that covers your APIs, you already opted in. And if you want to opt in, if you're don't have Sled tests, you just have to write the simplest Sled test that does the happy path of your system and covers your APIs, and Krampus will take it from there. But there are some issues that we have seen where Krampus can create a little bit of chaos. So it can break your tests sometimes, because a lot of the tests we saw that they were relying on some pre-existing system state. For example, some kind of site that was created manually and configured manually, some blog posts, some contact, and Krampus injecting basically garbage can mess this stuff up. And sometimes it will create alerts and noise in the logs, because it will generate errors that are not normally seen in production. And so what can you do? So we don't have time to go into this, but we have a detailed guide that you can read. It's called Krampus Victims Guide. And we have a channel for Krampus victims, so you can reach out to us. And that's basically it. Thank you.
Thank you.
We're on time.
Yep. Thank you.